A neuroscientist named Naomi Isenberger conducted an incredibly fascinating study. This study, when I first heard about it, I was just amazed at how simple and elegant it was in so many ways, and wondered, gosh, why didn't they think of this a long time ago? But honestly, they couldn't have conducted this study too long ago, because it relies on a technology called functional magnetic resonance imaging. Probably heard of it. MRI machines. You've seen them in hospitals where people get on these giant beds and they go through these giant tunnels. I'm no scientist, but what I understand is that these machines, they send a cascade of magnetic impulses into the body. And our cells, which have hydrogen in them, the hydrogen atoms somehow line up, which causes a radio signal of some sort to happen. Don't ask me, I'm no scientist. But this radio signal can be read as strong or weak, giving scientists a chance to see in a three-dimensional way with incredible precision what's happening at the deepest regions of the brain without having to open the person up. It used to be everything we knew about the brain was based on anecdotal studies of people that had gotten brain injuries. A guy in Vermont one time had a rod that went in a railroad accident straight up through his chin and to the top of his head. Somehow they managed to pull the rod out and he still survived, but he was a different guy afterwards. It was one of the first times it occurred to anybody that different regions of the brain may be responsible for different ways in which we function. Up until not very long ago, much of what we knew about the brain was from soldiers injured in wars or people injured in accidents, where things they used to be able to do they could not do post-insult. Up until just recently, we had studies where we would actually open people's skulls up and keep them in a low level of anesthesia and tap certain regions of the brain, and certain things would happen in their bodies. But that's the best we had. Now it's no longer necessary to open anybody up or wait for them to get injured. We can actually see with the precision that was never before possible what's happening in the deepest regions of the brain. The neurosciences, they're called, are among the harder sciences that exist right now. We're not talking about touchy-feely survey research. We're talking about precise science. Isenberger, in this study, she invited people just like you and me to come and sit in the laboratory with a little computer to play a video game. I never remember what the game was, but it doesn't really matter. Imagine it was volleyball. Imagine there's one person on your side of the net with you and two people on the other side of the net. You tap the ball to your partner, who then taps it to the people on the other side of the net. And it's all a video game. Isenberger has told you that there are people in the laboratory, in different places of the laboratory, just like you, who are playing the game. She wants you to believe there's real people there. It turns out it's not true. It's a fib. It's just a computer and you. Before the game even begins, participants say things out loud like, gosh, I'm terrible at these video games. My kids are so much better at these video games. I have terrible eye-hand coordination. Before the game even begins, the participants are expressing their fear that they will not fit in. Isenberger then places on each person's head a basket-shaped thing with wires coming out of it that is one of these magnetic resonance imaging machines. Like everything else in technology, everything's getting to be made smaller and more portable. But imagine yourself participating in this study, scientists watching your brain with precision never before possible. You tap the ball to your neighbor, who taps it to the person on the other side of the net, and it goes back and forth like this. For 5 minutes, Isenberger watches your brain. And then after 5 minutes, the computer's instructed to leave you out. So the other 3 players play, tapping the ball back and forth, but they never tap it to you. And then Isenberger watches your brain. And guess what? Guess how each participant's brain responds. And this study's been replicated many times now. But participant after participant, when left out of this game, they respond in exactly the same fashion as you would respond if somebody punched you in the nose. Not in a similar fashion, exactly the same fashion. A region of the brain that's called the dorsal anterior cingulate cortex fires away. It lights up in the brain. And scientists know what this means. Among the many things that are taking place when this is lighting up is that chemicals are being sent through the bloodstream that are designed to reduce swelling in tissue that is not even taking place. Chemicals are being sent through the bloodstream that are designed to repair cells, to reduce pain. It all happens in instantaneous time. Isenberger says, my goodness, if our brains respond this way when we're let out of a video game, we're playing with people we don't even know who turn out not to be real people, but we don't know that, for 5 minutes. What would it be like if there were people we did know, who we could see next to us, across the net from us? Or what would it be like if it was somebody you loved who didn't love you back? Or what would it be like if it was someone you loved who passed? Well, as Isenberger and other neuroscientists who've replicated this study since conclude, it's like being hit in the nose with a blunt instrument. Shorthand way of saying it, being left out hurts. Our body responds to being excluded in exactly the same way our body responds to physical pain. A group of researchers, by the way, out of Harvard picked up on this result and said, well, doesn't it make sense if that's how our body responds, that if we were to give people aspirin or Tylenol after they've broken up with their boyfriend or girlfriend, that they would feel better? And guess what they do? The researchers out of Harvard aren't saying for a minute, you just broke up with your boyfriend, take some aspirin, you'll feel fine in the morning. They're just saying you're going to feel better. And the reason you're going to feel better is because your body is going to respond as if you're experiencing physical pain. 5 minutes in a video game with people you don't even know.